Hello, I would like to show you a demo of another of the code examples from my book about WebAssembly. And this particular code example is from chapter 8, which is about running JavaScript inside WebAssembly. It's using this compiler called QuickJS, or this JavaScript runtime actually, called QuickJS. That is compiled to WebAssembly and it's able to run JavaScript inside WebAssembly. So here is a simple script that we can paste into our browser and we can run it and we can see the results here. So what it does is to sign a message that we are generating here with the current date and some other information and a random number. And we have the private key here that we sign this with, and we can run it multiple times and we see that we get a different signature here all the time. And the thing here, for example, we cannot interact with any of the browser specific things. So for example, if we try to write alert hello, nothing will happen here. Because we don't have access to any of those functions from within the JavaScript runtime. Trying to access the window object in some way is not possible either. Because it's not defined inside this secure sandbox that we are running JavaScript in, and this is because yeah, it's inside WebAssembly. It's not connected to the browser's JavaScript runtime, so we can only write things that is self-contained into this runtime. So, for example, this should work, and we also have kind of inserted the date object if we look at the sources here, and we can just take a look at that because. Here is here is actually the HTML loading this WebAssembly, and here we have the example script as you saw, and we are instantiating the WebAssembly module here, which is this QuickJS Rust WebAssembly, and we provide it with this clock time get method so that we can actually we can do things like a new date. That's possible. So if we write, for example, new date here to string, that will work. But again, we can also see that in the example, if I reload this again, we had some functions that are not part of regular JavaScript. So, for example, this sign message function. And this is something that we have provided from our WebAssembly code, actually our Rust code. So if we go back here to the source code of this again, we can see that in the Rust code base there is something called add global function, and we are adding this sign message. And you can see that here we are actually calling some Rust libraries for signing that message. So it's using a specific crate for that, which is from the Rust selection of crates. So all in all, running JavaScript inside WebAssembly makes it possible to run JavaScript in a secure way. You can actually take JavaScript that is supplied by the user, and this is common for example, edge or cloud hosting environments where the user is able to submit their own JavaScript code and run it in a secure way so that it cannot do other things that the capabilities it has been assigned. And that's it. If you want to kind of know more about this is from the GitHub project QuickJS Rust Wasm. We can just look at one of these. This is the project where I compile QuickJS to WebAssembly, and the other one is QuickJS Rust, where I combine the Rust and the JavaScript runtime and create a WebAssembly out of it. It's originally made for smart contracts, WebAssembly smart contracts on your protocol, but it can also be used in other use cases. And in my book, I will kind of describe it also just to compile it in the minimum way, so that you don't have the blockchain part of it. But the blockchain part of it is also very interesting, because smart contracts is also a very good example scenario where you would like to run user-supplied code, user-supplied JavaScript. And this is what this is all about, to be able to run this user-supplied JavaScript in a secure way. So that's it. Thanks for listening and watching, and see you later.